theorems. Only a couple of them are really going to get used a lot. And that's going to be mainly the first theorem, which says that if you have an entire row or an entire column of a matrix that's zeros, then the whole determinant for the entire matrix, no matter what its size is, will also be 0. Another one says that if 2 rows or 2 columns of any matrix are the same, that's rule 5, then its determinant will be 0. The last one that's super important is number 7. If a matrix is in triangular form, what this means is you either end up with the top triangle of the matrix being all zeros or the bottom triangle of the matrix being all zeros. Then to find the determinant of the matrix, all we have to do is multiply all the numbers along the main diagonal to get the determinant. So what that means is if I take the entire diagonal from either one of these, whatever these numbers are, and multiply them, this will be our determinant of the matrix, no matter what the size of the matrix. Now let's go ahead and use some of these theorems to answer the next couple of problems quickly. For example, if we look at problem A, notice that this is what we were calling a triangular matrix, because notice the top triangle of this matrix above the main diagonal is all zeros. So what theorem 7 says is to find the determinant of this whole matrix, all I need to do is multiply all the numbers along the main diagonal. So the determinant of this matrix will just end up being 7 times 6 times 4. So this gives us a total of 168 for our determinant of this matrix. That was pretty quick. The next matrix, notice that we have either an entire row or an entire column of zeros. Well, we said in, I believe it was theorem number 1, that if you have either an entire row or an entire column of zeros on your matrix, then the determinant will just automatically be 0 itself. So we're done. So these theorems can save you some quick time so that you're not doing those long-winded formulas.